In this video, you're going to learn what you need to know about alkanes and the fractional distillation of crude oil. Crude oil is basically a mixture of lots of different compounds that we call hydrocarbon chains. You all know what a mixture is, but science has got to give it its definition. Just remember, a mixture consists of two or more elements or compounds not chemically joined together. As I said, the compounds in crude oil are called hydrocarbons. This is because they only consist of hydrogen and carbon atoms. Most of these hydrocarbons found in crude oil are called alkanes. Well, okay, this page isn't as complicated as it looks. It's really just the same formula applied 4 times over. So alkanes have this general formula, CnH2n plus 2, which just means that for every carbon atom there's twice this amount of hydrogen atoms, and then you've got 2 more because one is needed for each end of the chain. So the alkanes that you will need to know are methane, ethane, propane and butane. Methane has only 1 carbon atom with 4 hydrogen atoms. Ethane has 2 carbon atoms with 6 hydrogen atoms. Propane has 3 carbons with 8 hydrogens. And butane has 4 carbons with 10 hydrogens. But you can figure out the number of hydrogen atoms in each by remembering the formula, so long as you remember the number of carbon atoms in each alkane. So here's a look at the number of carbon atoms in each hydrocarbon, which, as I said, you will need to remember. But then, to calculate the number of hydrogen atoms, you simply double this number and then add 2. So here's a look at the hydrogen atoms for each hydrocarbon. In crude oil, as the different alkanes are in a mixture and not chemically joined together, it is possible to separate these substances by physical methods such as fractional distillation. So what is fractional distillation? Well, fractional distillation is the process by which the many hydrocarbons in crude oil are separated into fractions, each of which contains molecules with a similar number of carbon atoms. This is done by evaporating the crude oil and allowing it to condense at a number of different temperatures. So first, this crude oil is being pumped through the furnace to evaporate it. The fraction that doesn't evaporate now flows down to the bottom of the column, and the hot vapours, now in the gaseous state, rise through the fractional distillation column. The column is heated from below, so the vapour cools as it rises. When each fraction reaches its boiling point, it condenses. The fraction is now separated from the rest of the crude oil. It can then be pumped out through a pipe as a liquid. The higher up the column a fraction is separated, the fewer the number of carbon atoms in its chain. The unique number of carbon atoms in each alkane gives the fractions unique properties. You should be able to link the size of the molecule with these properties. You will need to be able to say how the size of the alkane affects its boiling point, which is the temperature at which the gas changes to a liquid, its viscosity, which is a fluid's resistance to flow, which can be seen here. Bitumen has a higher viscosity than petrol, and its volatility, which is how easily it's ignited. This little table summarises what you need to know for this. The molecule size, boiling point and viscosity are all greater the further down the column the fraction is removed, whereas the volatility increases the further up the column the fraction is removed from. So that's all the information you'll need to remember for this video. Now it's time for a practice question from a past paper. This question was asked in June 2012. Write a number 2, 3, 4 or 5 next to each stage so that the description of fractional distillation is in the correct order. Numbers 1 and 6 have been done for you. So pause the screen now and see if you can answer this question. You should have answered this question by now, so this is the answer. Why don't you try and answer some of these questions? If you're struggling, simply re-watch the section of the video that you found the hardest to understand. Okay, pause the screen now. Good luck!